All right, guys, on exit slip 7-2, we're trying to use inequalities here. Our goal is to use inequalities to help us solve some real-world problems. All right, so here's our situation. We have at most $12 to spend at lunch, and you want to get a sandwich and a few side dishes. The sandwich is $6, and each side dish is $1.75. Okay, so I need to define a variable and write an inequality that'll put this situation and represent it. All right, so a variable is what's missing and what we don't know, and we're trying to find how many side dishes he can afford. So I'm going to call it D for side dishes. That's what we're trying to find out, how many we can afford for side dishes. So we're supposed to explain how we can use this inequality, use an inequality to help us. So I've got to write an inequality also here to solve this. So I'm going to write the inequality, guys, actually up here where I have a little more room. So this is where your brain has to put together what's going on here. And I see that I'm buying a sandwich and side dishes, and then it has to be less than or equal to $12. And we're going to not worry about tax if there were tax involved. Okay, we're not going to worry about that here. So I know a sandwich costs $6, and I have to add $1.75 times each side dish. Okay, you got to take $1.75 and multiply it by every side dish because they all cost that, and it has to be less than or equal to $12 because that's how much I have to spend. I could spend it all, so it can equal exactly, so it's got to be less than or equal to $12. If it's less, I'll get some change back. All right, so let's go ahead and solve it again. Explaining it, we're just going to kind of model how we would do this like we did with an equation, and you're just trying to get D by itself. Isolate that variable. So we know we want to get rid of the adding or subtracting first. So if I have $1.75 times each side dish, if I add 6, I take away 6, and that leaves me with nothing. Looks like it never happened. So I'm left with $1.75 times each side dish. Has to be less than or equal to, and remember to keep it balanced, if I take away 6, I have to take away 6 here. So $12 minus $6 is $6. So what this tells us, guys, for explaining this, we just took the sandwich price off, and that just leaves me $6 to spend on side dishes. And I know they're $1.75 times each one. So I could do some trial and error here, do some thinking. I know of 2, if I double this, it's going to be over $3. So that's already to 3. We're over halfway there. So I'm thinking maybe 3 or 4 probably, just using my common sense here and substituting in some numbers is what I can afford. But let's do it mathematically here. We know if we multiply times $1.75, D times that, to undo it, I divide by that. I do its inverse. That's like it never happened, so I'm just left with D. And if I divide one side by $1.75, I must divide this side by $1.75. So D has to be less than or equal to, and if you take this and divide it, guys, you're going to get an answer of 3.42, and it just keeps going. Okay, which means I could afford 3.42 sides, or a little, that's a little under 3.5. But you can't buy a half of a side or a portion of a side. You can only buy a full side. So really, guys, I could say that D, I can afford 3 side dishes, and I get some change back. And we can figure out how much. It doesn't ask us to do that, but we can afford 3 side dishes is what I would be able to order there. Some of you might just, when you got here, you could have just taken it times 2 and times 3 and found out if you take it times 4, it's too much. $1.75 times 4 is over $6. So you would know it would just be 3. You wouldn't necessarily have to finish this way. A lot of you have the math number sense to be able to do that. So make sure you get these things written down, and this is a classic problem of how I could use an inequality in real life to help me to figure out how many side dishes I could buy.